We have two learning goals today, and what we're going to do today, we've already have some prior knowledge for this, so this is all not new to us. I can determine a line of best fit for a set of linear data. We have worked with lines of best fit already, also called trend lines, when we worked in our lesson back on scatter plots. And we drew the line of best fit, the trend line through the data that best represented the data set. Does it have to go through every point? Does a trend line or a line of best fit have to go through every point on the scatter plot? No. Scatter plot means the points are probably going to be scattered around, but they should, sometimes they'll have a pattern, and we're looking to see if they have a linear pattern. And if they have a linear pattern, then the next thing we're going to decide is I can determine and interpret a correlation or the correlation coefficient. Remember, we talked about correlation, a data set having correlation. What types of correlation are there? Positive, negative, or none. There's no correlation between the two sets of data, the two things in the data that you are comparing. So either they'll have a positive correlation as one increases, so does the other, or they'll have a negative correlation as one increases, the other one decreases, or there's no correlation, they're just all over the place. Okay? So we've already done that. So today what we're going to talk about is, when we talk about a line of best fit, the calculator can get the best one for us. It does some math, some arithmetic, it has some stuff it does to decide what's the best place to put this line of best fit through the data set. If it is a positive correlation, what should we expect that line of best fit's behavior to be? Oh, what do you think? If it has a positive correlation, this data set, what would we expect the line of best fit's behavior to be? Richard, help her. Rising from left to right. Yeah, positive correlation means positive slope. Okay? If it has negative correlation, what would we expect the behavior of the line to be, class? Falling from left to right. If there is no correlation, can there be a line of best fit, really? No, because we wouldn't know where to draw it. We wouldn't, if it's kind of all over the place and we don't see any sort of a pattern of behavior going on with the point, we wouldn't know whether this line should be going from left to right up, it should be going from left to right down, it should be horizontal, it should be vertical. We don't have any idea of what it should be. So what we're going to do is we're going to use the graphing calculator to find the equation of the line of best fit, and then from that equation we're going to interpret some things that we can say this is what we can expect from this data set. Okay? So this right here, you already have this sheet in front of you. It says use a graphing calculator to find the line of best fit and the correlation coefficient for the data at the right. It's just a very small data set. And they've already done it for us, and this is what we should get when we're done, but we're going to practice with this one. So let's follow the directions. Turn it on, turn your calculators on. Step 1 says press stat, find the stat key. Step 2 says press 1 to edit. In other words, we want the first command, the number 1 command, edit, so we can just press 1 or we can press enter. 3 says, enter the x values into list 1. Now there should be an L1 and L2 on your screen. Do you see that? On your graphing calculator? There's probably already going to be data in there, right? I want you to cursor up, arrow up so that the list name is highlighted. And then press the clear button and arrow down and it'll dump the data out of the list. Any other list that has data in it, do the same thing. Cursor up to the name of the list, press the clear button, arrow down, and it'll dump the data out for you. They're telling us right here in the data set which ones are the x values and which ones are the y values. So in step 3 it says enter the x values into list 1. So you're going to put 1 in, 3 in, 3.5 in, and 5. Everybody in here except Gilberto has already done this when we did scatter plots. Have you worked with graphing calculators before? No? Is it going all right over there so far? You got Allie, she's good. Shut up. Oh, she's just looking kind of scared now. Okay, anybody not being successful getting their data into these lists? So we can help you out? After you have both list 1 and list 2 with the x values in list 1 1 and the y values in list 2, you're ready to move on to step 5, where it says press the step key again. And then it tells you to use in step 6 the right arrow key to select calc. And press. Now it should have a screen that's got like a 1, 2, 3, 4. We want command 4, so it says press 4 to select a linear regression. And step 8 says press enter. Now we're not going to do this part right here on the actual graphing calculator. What I want right now is I want to know, do you have that box of data information on your screen right now? You should. And would you check to see if it matches? Because it should. We all use the same data set. We should all get the same A value, the same B value, the same R squared value, the same R value. What might happen is you might have a screen that doesn't have an R squared and an R on it. Anybody have that? No R squared or R? Yours does not have it, but it has the A and the B. Okay, follow my instructions. Anybody else? So the second key 0. It'll take you to the catalog. You're going to scroll down till you find the command called diagnostics on. Yes, when you find diagnostics on, you're going to press the enter key.
Oh.
It's not the same.
Oh no.
Did you put this down? Yeah, probably check. So we're putting this data set in. We should get this information. And then what we're going to do is we're going to hear what I have to say. Why is it A and not M? When they say A, they're really talking about M. So A is the value in front of X, known as our slope. Okay, so we just have to understand that in math, sometimes something has more than one name. Okay? So when they have an A value, they're really telling you what the slope of that line is. The B value is going to stay the same. What is the B value again in an equation? The y-intercept. Okay. So we take from this information. Did you get it back again? You're going to have to run through all the steps again. Okay. Okay, so what is the slope of this line of best fit? What is the slope of this line of best fit? Help me out. What is the slope of this line of best fit? Pardon? Remember, A is the same as M. What's the slope? Let's round it to the nearest hundred. 1.25. 1 in 2,500. We had to round it. What is the y-intercept of this line of best fit? Negative 1.41. Negative 1 in 4,100. What would we expect? Tell me something about if I had you graph this right now. I had you put the equation into y equals. What would the behavior of that line be? What could you expect on the graph, Corey? It'd be falling from left to right. Why?
Because it's a positive. One's a negative.
Because one of them is a negative. Which one has to be negative for it to be falling?
Slope.
The slope. Is the slope negative? No. So we should expect that if we actually made this scatter plot, those points should be clumping together, kind of rising from left to right, with a line of best fit rising from left to right through them. What would we expect because of that negative? What's that tell us? That's where it's doing what? Crossing the y-axis. So it's actually crossing the y-axis at a negative 1 in 4,100, so it's crossing below the origin, isn't it? Okay? So now we got to talk about, here's what the thing that is really important that we need. They wrote the equation here for us. Would you circle that in your notes? That the equation of this line of best fit with rounding going on is y equals 1 in 2,500 x minus 1 in 4,100. Now on your screen, it gives you an R value, okay? And it should match the one that's here, which is 0.9935198. We're gonna round that to the nearest 1,000. So they are saying right here, rounded to the nearest 1,000, that R value is a 994 thousandths. And notice it's a positive R value, which means then, just like we said the line of best fit would have a positive slope, that correlation would then also be positive, wouldn't it? So if the R value is positive, that tells you there's positive correlation going on. And here's the thing that's also really important, and I want you to maybe box this or something. The correlation coefficient is R. When R is close to 1 or to -1, it'll be somewhere in between those, inclusive, it can be. There is a very strong correlation. So the closer it is to -1, the stronger that correlation is to being a negative correlation. The closer it is to +1, the stronger the correlation will be in a positive correlation. So when we talk about correlation, we use an adjective with it. We say it is strong, maybe moderate, or weak. Positive correlation, strong, moderate, or weak. Negative correlation, or maybe there's just no correlation at all. Okay? Where do you suppose there would be no correlation at all? When the R value is what? 0. If it's right around 0, that R value, that means there's no correlation in that data set. Okay? So now let's go and do this one that has not been done for you. Okay, go ahead and follow the instructions up above, but you're going to have to clear your old data out. So remember, you go to the list name, you press the clear key, you arrow down, and it dumps it out. And you can put your new in. But before we do that, we've got to decide what are the X and what are the Y values in this table. So we have 4 students who run during the week, and it shows how long it takes them to run the mile. What would control what? Would the number of times they run a week control their time? Or would the time that they run it in control how many times they run? Which one's the controlling factor in this? You're going to make that decision before you ever make a scatter plot. Yes? Number of times that they run. So we're going to say that these are the X values. How many times they run a week should control the time it takes them to run the mile. So put an X and a Y to the side of those, and now you know which ones are going to go in your X list and which ones are going to go in your Y list. And I want you to complete it all the way through here, okay? I want you to do this part right now on your own. Show me that you can do that. We just practiced. And you have all the steps above for you. Anybody having trouble and just trying to sit there and pretend needs to get their hand up. Pretending does not help you learn. So we're going to round the A and the B values to the nearest 100. We're going to round our R values to the nearest 1,000. We're going to describe correlation with 2 words. Strong, moderate, weak, positive, or negative. Or the other command on the other or there we go. Yeah. Okay, just so you don't think I forget about you back there in the corner, Austin. Do you want to tell me what the A value is rounded to the nearest 100?
Negative 1.5.
100. That's tenths.
Oh, negative 1.51.
Okay, Yeah, that sounds more like hundreds. Negative 1 and 51 hundredths. Anybody want to agree with it? You should all. Okay. B value. B value. Who wants to offer that one up? Maddie? I'm sorry, what? Okay, 12 and 90 hundredths. So that 0 matters. In other words, whatever was in the thousandths place wasn't being rounded up to 91, so we write 90. That 0 is important there. So 12 and 90 hundredths. So then the equation of this line would be y equals 1. I just went with what I know. Okay, what's the R value rounded to the nearest thousand for this one, Billy? 0.9. Okay. So 931 thousandths. Okay, everybody want to agree with it? Yeah, got this? Okay, so what does this tell us then? Rachel, you want to disagree? No, you want to answer the next part?
A strong negative correlation.
Okay, and so was this positive or was this negative, Billy? It was a positive. Huh. Now, why would we know that it should be negative? Why do we know that, Macy? The slope is negative. So that means the correlation has to be negative, which means the R value should be negative. So it should be negative, shouldn't it? So now that tells us it's really close to negative 1, isn't it? 931 is pretty close to 1,000. Really? So we would say it's strong, and it is negative. So we would expect that these points, if we actually made the scatter plot, would be falling from left to right on our graph. The line that's best fit through them would also be falling on our graph, okay? And those points should cluster pretty close to that line. That's what strong means. All those points should be pretty darn close to that line. I want you to look in the middle of page 287 right now in your book. Middle of page 287. Right in the middle, there's that tan color table that says properties of the correlation coefficient R. I want you to look at those 5 graphs and read through that for a bit. I want you to get a visual of what these would look like with R values attached to them. So visualize that when the R value isn't very close to -1 or to +1, when it's not very close to it, are the points kind of further apart from each other? They're not so clustered together, are they? They're more clustered together the closer that R value gets to those -1 or that +1 R value. So it's really describing for us, here's what the behavior of those points is like on the graph. Here's how strong their correlation is, or moderate it is, or maybe weak it is, whatever, okay? So now, this data set then, apparently there is a correlation between how many times you run versus how fast you run the mile. Apparently there's some sort of a correlation to that. But the next thing we're going to explore is, just because there's a correlation relationship, does that mean there's a causation relationship? So in other words, there's one cause, the other doesn't have an effect. Because you can have correlation and not have any causation. Okay? There can just happen to be a correlation between, we collect a whole bunch of data on math scores for girls and for boys. And we happen to notice that there is, the more girls there are in the math class, of course I'm going to go this way, the more girls there are in the math class, the higher the average of the math class is. The more girls there are, the higher the math scores are. So it shows there's a correlation. But is there a cause? In other words, does having more girls in the class cause the math scores to be higher? What do you think? No, probably not. Probably not. There might have shown to be some correlation that the more girls there were in the class, the higher the math scores got. But there's no necessarily cause there going on. How about this one? How do you feel about this one? Is there, remember our controlling one is how many times that you do practice runs. Do you think the number of times you practice run could cause the effect of bringing your time down for running a mile? Yeah, it seems like that seems likely, doesn't it? That if the more you run, the better you should be able to run the mile, the shorter amount of time. So we're going to say, in this case, it is likely. Oh, don't put that. There would be causation, be a causation relationship. And causation really is a word. There would be a causation relationship. And of course, this is in our, our humble opinion. It seems likely the more practice runs you do, the time you run the mile. I could probably make this even shorter, yeah, but of course I'm dragging it out. The time you run the mile should get better, should get shorter. So it does seem like one does cause an effect on the other. Not because there's correlation, but because, you know what, that seems likely. That's what should happen. Okay, now we're going to interpret the meaning of slope and the y-intercept. And we are so far at this, but we're going to get that in. What is the slope of this one? The slope is what? Let's write it. The slope is? Okay. Which tells us what? What does that tell us? So this is not a fraction, is it? But we can make anything into a fraction by putting it over 1. So we would have our y's and our run. We would have our y's over our x's. So we could put this over 1. And we could say we've got the 1.51, negative 1.51 upstairs. And we got a 1 downstairs. What are the y's in this situation? Time to run the mile. Okay? How long it takes you to run the mile in minutes, right? And what are the x's in this situation? How many practice runs you do? Okay, so we got a negative 1.51 upstairs, and we've got a 1 downstairs. So what is it telling us? For every 1 practice run, your time, you can cut your time down. How many minutes? Okay, for every practice run, you can take 1 51/100 minutes off your time. Now, this is just what this is telling us. It doesn't mean it's automatically going to happen. But according to these 4 people and their practice runs and their times running the mile, this is the result. You know what they're going to say to each other? Well, it appears that every time you add a practice run, we can count on taking about 1.5 minutes off of our time that we run the mile. Okay? So that's how we interpret and tell what the slope means. We have to address both things, right? Okay, what's the y-intercept? What is it? 12.90. The y-intercept is 12.90, which tells us y-intercept. Oh, that's a point on the graph where which value is equal to 0? The x value is equal to 0. X is the what again? Number of runs. So when you have 0 practice runs, without any practice whoopsie, too far, without any practice runs. You run the mile in about 12.90 minutes. And we don't do abbreviating in our sentences, by the way. So this is according to this data. So this doesn't mean it's going to be you. You're going to go run the mile today. You've done no practice. You're going to go run in 12.90 minutes. But if these 4 students that collected this data, this is what they could say, you know what, according to our collection, this is what we can kind of expect. Any questions? I will not be stamping papers tomorrow with half-hearted effort. I'm tired of you not being able to tell what slope and y-intercepts represent. Not being able to write out when it asks you to say, why is this your answer? Yes, Rachel?
Why is the y-intercept 12.90, but when you go up to the top of where the graph, the points are, it's 0 to 14?
Okay, so again, does our line necessarily go through that point? This is a line of best fit, right? Does it go through all the points? No, it's kind of, it might take 1 or 2 of them. So this is kind of like saying on the line of best fit, this is where we're making our prediction from. Okay, that makes sense? Okay, anybody else? Okay, then let me stop these.